Good morning to our audience in this event. My name is Martin Maas. I am the teacher and the tutor of Gerardo and Mariana. Mariana, please go ahead.
Hello, my name is Mariana Gil.
And Gerardo Blanco.
Our project is Prototype Chinampa Pet, alternative for the restoration of red mangrove in the Bacalar Lagoon. We are from Bacalar, Quintana Roo, Mexico. Our lagoon, commonly known as the Lagoon of the Seven Colors, has a great variety of plants, fish, birds, insects, and stromatolites in its ecosystems, and it's formed by sinkholes.
General objective: to build a prototype of Chinampa with reusable material, PET, for the cultivation of mangrove, for the restoration of the wetlands in the Bacalar Lagoon. Specific objectives. The specific objectives are to construct a Chinampa with reusable material, identify areas of the mesh, monitor water, physical chemical parameters, growth and survival, transplant, and determine the feasibility of the application. Hypothesis. We consider that the use of the prototype Chinampa made with reused material PET is a reliable method in the cultivation of red mangrove for the restoration of the Bacalar.
Methodology. The top was constructed from a rectangular base of plastic bottles, which are tied to rafting. This structure is covered with old tarpaulins and filled with well water. And finally, the shade net is placed.
Prototype of Chinampa. The prototype are bottles that are cut in the upper part and small holes are made in the lower part. With a soldering iron, they are fitted in the groups of 3 and leveled. Collection. The Lagoon Bacalar is located in the southeast of the Mexican Republic, south of the Yucatan Peninsula. It is approximately 55 kilometers from south to north and width and the northwest part of the 5 meters and the wildest part of 2. Lagoon to Bacalar Ecological Park, located in the northern part of the city of Bacalar. The samples were taken in the southern and the northern part of the reserve.
Sample collection. For the collection, the Chinampas were labeled with their key, date, and place. We use a boat for places of difficult access, and by means of nucleators made with PVC, the sediment was collected and deposited in the Chinampa. The seedlings were collected from the lagoon and placed in a bucket with water, and then planted in situ.
Monitoring in the Chinampa. We added sediment to the Chinampa and transported into the plastic container. Into the plastic container, we begin to monitor its growth, pH, conductivity, temperature, and total dissolved particle.
Restoration site. We visited different sites in the lagoon to see which ones could be feasible for restoration. After the assessment and determination of suitable conditions, we decided to transplant them in the area south of the Bacalar Lagoon, approximately 3 kilometers from the city.
Restoration process. We transported the mangroves in the plastic container for trade protection, dug 3 holes with a distance of 1 meter between each one. With scissors we cut in the Chinampa to remove the mangrove and to place it in its environment. Finally, we placed a 50-centimeter roll and with the help of flexometer we monitor its growth.
Survival results. In left graph, we can observe the percentage survival in the Chinampas with a 60% loss for extraordinary cases, 33% of plants dead, and 50% of plants alive. In the right graph, you can observe from this 50%, the results were all the plant survival in the environment, with a 100% of plants alive. Growth. We can observe the growth and adaptation of the seedlings in the Chinampas since December 2020 to August 2021, where we can see the growth and adaptation of the seedlings in the height, leaves, and color of the plants. In the following graph, we can observe the growth of the seedlings in the Chinampas and in the restoration site. where X represents the key of each seedling. The first 3 bars are the growth of the main growth in the Chinampa, and the other 3 are the growth in the restoration site. We can see that the restoration site X14 reached a height of 48 centimeters, followed by X17 with 38 centimeters and X18 with 33 centimeters. In the Chinampas, you can see that X17 had a height of 38 centimeters, X18 30 centimeters, and finally X14 10 centimeters.
Physical chemical parameters. Conductivity valves are between 300 to 750 microsieverts. Total dissolved particle matter valves range from 0.17 to 0.42. The temperature was 20 to 30 degrees Celsius, and the pH valves were 5 to 6.
Conclusions. The Chinampa prototype is an example of sustainable potential and is accessible, economical, and safe. Using our prototype, we achieve mangrove cultivation and development with a clean and renewable alternative. It fulfills the objectives and is an example of sustainable potential with a survival rate of 50%, demonstrating that through an accessible, economical, and safe method, we managed to cultivate this species so important for our lagoon that will benefit its ecosystems and all related living beings. The prototype allows us to develop a clean and renewable alternative. Our project focuses on Goal 15 of the Sustainable Development Goals, which mentions protect, restore, and promote sustainable use of terrestrial ecosystems, having results not only for the good of the community, but also for the whole world. It's all. Thank you so much.
Thank you.